Welcome, everyone, to this episode of Build America, the national podcast that is capturing and sharing the very heartbeat of construction and development. And I'm your host, Kerry Smith, owner of CNR Magazine. And with us today, I'm delighted to announce is Tim Gunn, who is Vice President Construction at Alberici Constructors. And Tim has spent more than 30 years at Alberici. He's worked a lot in the commercial building and healthcare group markets. And since 2006, he's also focused on large replacement hospital projects. And in the last 3 years, I know, Tim, you've been a big part of leading Alberici's effort on City Park Stadium, the Major League Soccer stadium in St. Louis. So welcome, Tim, to Build America. We're glad you're here with us today.
Yes, Kerry, it's great to talk to you today. Thanks for having me.
Absolutely. Well, our topic today is prefabrication design and engineering. And before we started rolling here, I know that you were sharing with me, Tim, about how prefabrication design really crosses not only the healthcare sector, where a lot of us are familiar with seeing it, but also in sports arenas. So if you could maybe give us a high level explanation or introduction to what does prefabrication design and engineering entail in Alberici's world and in what you design and build.
So I think for my work that I've been involved with in the past several years, we have seen a lot of the challenges that the rest of the industry has seen. And that is supply chain challenges, extended material lead times, challenge in workforce availability, challenges in making our projects safer and more efficient and more cost effective for our customers. And a lot of that drives us to want to build as many of the components as we can offsite, that we move a lot of the work out of the direct front lines of the construction work and into controlled manufacturing environments where we have better control on quality, better control on safety, better management of materials, and it helps the projects be better and ultimately turned over to our customers, in some cases a lot faster, so that they can start to utilize their investment in their capital buildings more quickly.
That makes sense. As you were speaking, I thought for a project the size of City Park Stadium in St. Louis, the new MLS stadium, how much room? You must have a gigantic one or more shops that you even prefabricate these materials in. I can't imagine the span of square footage that you have to be able to do that.
Right, City Park was an extremely important project to the city of St. Louis. I'm very proud to have participated in it. A lot of the components on the project were in fact prefabricated. Something that a lot of people know if they're familiar with sports facilities. A lot of the seating sections, the stadia, the seating bowl is precast concrete. That's a really easy example of making concrete in a factory and bringing it out on a truck and setting it in place is a lot more efficient way to build that type of a component. It's in a controlled environment. There's not scaffolding or formwork that has to be put in place on the project site. It goes in place a lot quicker. It utilizes cranes to go in. And so that's really a very easy example that people might be aware of in terms of when we talk about prefabricating. And also, like City Park, as well as our other commercial healthcare projects, a lot of the mechanical systems, electrical systems, we look to prefabricate. Mechanical rooms will have pre-assembled pump skids where pumps and piping and electrical control panels are built into a rack or system that's made in a shop that comes out on a truck, gets set in place. We actually at City Park, a lot of the public restrooms where there are rows of toilets or urinals, the plumbing that's in behind the wall can be made and was made into racks in a plumbing shop. And then we had instances where overhead electrical racks were assembled offsite and brought in on a truck and lifted into place. A lot of the structural steel assemblies we send from our Alberici fabrication shop make steel components that are about as large as we can ship on a truck so that the connection details are reached on the ground at shop level rather than putting someone up in a lift to try to do a steel connection where it might be a little less safe or there might be weather impacts. And so all of those are instances where it is a superior construction process to have that work be on the ground and inside rather than up in the air out on the middle of a project site.
That makes a lot of sense. As you were speaking, Tim, I really started to see the parallels when you're talking about mechanical systems and plumbing and the commodes and everything else. I know Alberici is so well known as project partner on the SSM hospital, St. Louis University Hospital, that went up several years ago. And I thought at the time I was talking with you all about those same things. And in my mind, I guess I didn't think through the prefabrication techniques to know that, a lot of what you're speaking of, the bones of the stadium would be, similar in a sense to the systems in your healthcare facilities. And that's kind of amazing to me that that would be standard to some degree on some level.
Right. At St. Louis University Hospital, if you recall, we spoke on that project, similar, and there are very complex mechanical and electrical systems on that project. We prefabricated the patient room bathrooms and brought the bathrooms out in units, made them in an offsite warehouse and trucked them in and hoisted them onto the floors. And we also pre-assembled the patient room head walls that has the med gas and electrical outlets in both the ICU and the typical patient rooms. And so again, those are components where there's lots of benefits to be moving the work offsite where it can be done in a controlled environment. We can, in the warehouse or assembly line environment, if you will, we can control the amount of material waste. We can handle trash better. We can, if you think about if we would have built the patient room bathrooms actually in the building, which is an 8-story building, we had temporary elevators, and the work hours that we're able to expend on the prefabricated bathrooms offsite and early are work hours that we are not expending on the project site. So the project's less congested, there's less trash to manage, there's an easier flow of the rest of the workforce, and it helps us get the rooms when we set the bathroom prefabricated component and then build the room around it. It lets us get from building enclosure to finishing those rooms a lot quicker in the context of the overall schedule. So there's huge benefits to it, of course.
It sounds like if there's, in terms of preciseness, I don't know, I'm trying to think the best way to ask this question is, does prefabrication demand more preciseness because things are being rolled out as a unit? I'm not that your jobs aren't precise anyway, but versus building something in the field. Talk about that a little bit.
Yes, I think it does. And that's really the trick about prefabrication is that it really takes planning. And that's why when we do prefabrication on our projects, we prefer to be selected earlier, to engage with the design team earlier so that we can look at, again, if we're talking about a bathroom that's in a room, we want to make the bathroom have walls on all the sides, not where it's pushed up against an outside wall, because if it's against an outside wall, you want to have a unit that has a complete perimeter so you can pick it up. So there are a lot of reasons to want to get involved with the design about how pipes are routed, about how electrical is routed, how are the connections in the building when the prefabricated unit arrives on site. What are the tolerances of the concrete floor that the prefabricated bathroom is going to sit on so that we know what to expect, or we make accommodations for there being some tolerances in the connections. But really, the prefabrication really needs to be thought about in a project early, because that's really where the benefits come from, is being able to coordinate with the designers so that the designer and the customer and the contractor are clear about what components want to be prefabricated or modular components. And then the work site and the prefabricated piece need to be coordinated in a way that when the piece comes out, it fits. We've seen maybe it's been longer now because my career's been long, but we see 3D modeling and building information modeling and 3D designs gives construction teams more confidence about what the site is going to be like when a prefabricated component comes out. That if the building is 3D modeled, if the work is planned, our tradespeople put the work where it's supposed to go, then a prefabricated component is likely then to fit, where if that planning is not done ahead of time, then it could not fit, and then you're doing rework, and then the benefits of it are lost.
Oh,
So
I'm sure.
there becomes a very important upfront planning piece for what will be prefabricated so that the benefits are realized.
For sure. As you were talking too, I know I had asked you a little bit about the term integrated project delivery, and I wondered if prefabrication requires and maybe promotes that sort of design build scenario versus like a hard bid where everybody's doing their separate silos and pieces. Is a lot of this work tend to be
Well,
design build in nature?
Well, maybe design build, maybe design syst. Certainly, it would be a preference to have people that are building the work to be able to influence the design in some way. I think the typical or traditional design, bid, build delivery, where the designs are completely finished, it would be more challenging to prefabricate. It might involve some re-engineering, redesign, and there could be some opportunity lost in terms of really prefabricating. I think another piece is that at least the projects that we're involved with are a lot faster tracked. And so there really is a need to do early procurement of materials so that the prefabricated pieces can be designed, procured, constructed before the site needs them. And typically in the design, bid, build, schedule, there's not a large interval between a bid and a contract award and work starting in the field, that the planning and prefabrication duration could be squeezed to a point where prefabrication may not help advance the schedule.
That makes a lot of sense to me, and I'm sure to our listeners. What about sustainable materials? And I know that has to do with procurement and supply chain, everything else, but are sustainable materials and solutions part of the prefabrication equation, depending on the project?
What I would say is that when we do prefabricate and are doing components of the work in a shop environment, we do find much more efficient use of materials. We find less waste. We find easier trash management. We actually find that the workforce that's doing it can be efficient because it's very repetitive and very close together. And so that's all better for our environment. Whether a metal stud or a wood stud or a tile, or whether the material or component itself is a renewable wood product, I don't know that that really is consequential to the prefabricated component.
Makes sense. Tell us about some, we shared a little at the beginning, but if you can share a few innovative and fun projects you've been associated with regard to prefabrication, maybe a healthcare project or two, the little bit more about the sports venue, and you've got others that are you're in the middle of right now that even if you can talk to generically that represent.
I think the first real piece of prefabrication that stood out to me was back at St. Clair Hospital in Fenton. And there was a large piping run that went through the basement of the building, and it was assembled by Murphy Company, our trade partner on that project, brought out the racks of pipes with large steel, rolled it into place and hoisted it up and put it in the building. And a couple days after the pipes, this assembly went up into the ceiling, the crews had not quite gotten to the point where they had taken the wheels off of these assemblies. And so the wheels were up in the ceiling on the steel racks. And that just struck me as, you can really see that's a remnant of, we were able to make that big piece and just roll it right into place. And it's way more efficient than what we used to do with, trying to bring small cranes or rigging to try to get big pieces of pipe up into the ceiling.
Are you talking like 80 feet or how, like, I'm trying
No,
to just picture.
probably a 20-foot ceiling height
Okay.
inside of a floor of a building.
And the racks, like the size of those.
Probably 40 feet long. I mean, the prefabricated pieces that I've been involved with, the limit really is the size of a piece that can fit on a truck. The highway over the road trucks. The bridges are typically 13.6. You have a long trailer, and if it can fit on a trailer, it can go under the typical highway bridge. That's pretty much the limit of what we would want to prefabricate. People can obviously get more creative with oversized loads and other pieces in special instances, but on a pretty typical building project, I would say that what we can truck is about the
Sure.
size of what we would prefabricate. Now, I think from that time back at St. Clair, in the years, really the technology in terms of 3D modeling has really advanced. The technology that's used now in terms of layout in the field to make sure that work like walls or hangers, other piping systems are exactly where they're supposed to go, really allows people to be more confident in what they're prefabricating. To think about other projects, if you look and walk on a floor early when there's overhead mechanical rough in, you might see one single pipe in a space before anything else, and it'll have a lot of weird and odd twists and turns in it. And it won't make sense until you start to see the other work that goes in after it on how it twists and turns because it was coordinated in a 3D model and it's where it needed to be. And now the rest of the pieces will come in, go where they need to be.
I don't know if this is something that affected prefabrication from a budget standpoint, but do fuel prices play into whether you prefabricate if you're moving? I don't know what distances, you're moving them from the shop to the project site.
So the conversation about cost is significant because prefabricating is not necessarily first cost less expensive. When we prefabricated the bathrooms at SLU Hospital, for example, if you look at the price of the bathroom unit as a unit and said, well, we had to make the studs bigger, so we had to hoist it, we had to lease a warehouse, we had to truck it, we had a crane to put it in place. If you just took the hard costs, it's probably not less expensive. But if you start to look at what efficiencies do we gain by moving work hours earlier, what efficiencies do we gain in cleanup labor or less congestion on the project site, in having to have the man and material hoist on the site for fewer weeks. Those are indirect costs that are very real, but also very challenging to quantify. Most of what I think would drive prefabrication would be spending some money to try to have higher quality, less risk, and a building that the owner can utilize quicker so that they can start to activate whatever return on their investment that they're looking for. There are companies now that prefabricate elevators, an elevator shaft with an elevator built in it, and bring it out and set it on site. And elevators that's an important part of the project. It's an important part for the interior circulation for the rest of the work. But that elevator, if you're just talking about the price of the elevator, that prefabricated elevator would be more expensive by itself than if you were going to buy a traditional elevator. But that's where we look at what serves the project, what serves our customer. How do we look? There's lots of other challenges too in terms of prefabricating on how we work with labor, local labor, how we work with code officials or the inspectors that are on site, the AHJ, where they might not be typically used to inspecting a prefabricated piece. So there's a lot of conversations and a lot of planning that goes into deciding and executing large prefabricated components of a project.
I bet your success with this and so many other levels of scope of your project, but with the MLS stadium is going to lead to more work involving prefabrication on other sports venues. I don't think of Alberici initially connected with that. I tend to go to healthcare in my mind, but are you working on any other sports venues at this time that you can
I'm
talk
not.
about?
I'm
Yeah.
not.
Okay. That's okay. Because your specialty is kind of more in the healthcare arena, isn't it? Normally.
It's mostly been in healthcare and other commercial building work here in town.
Sure, that's a lot. Well, we have been speaking today with Tim Gunn, Vice President Construction for Alberici Constructors. And Tim, it's always a pleasure to learn from you about building information modeling and how it affects prefabrication and just the whole safety piece. We'll have to have you back on because I'm sure that translates into savings for ensuring the project itself and building building owners and the like, but I just appreciate you carving out time to learn us some good stuff today on prefabrication.
Well, you're welcome. I enjoyed the conversation.
Thank you. Come back and see us again soon.
Look forward to it.